Hey guys, am I audible? Can you see the screen? Of course you can. So yeah, thank you for coming. I know it is clashing with Werner's keynote, so we appreciate even more that you are here and chose us. With that, I'll give it to Ed. Before that, sorry, I forgot to introduce myself. I'm Rahul Popat. I'm the Senior Solution Architect at AWS. Been with AWS for over close to 6 years now, based out of New Jersey. And yeah, I'm with my colleague, Ed.
Hi. Good afternoon, everyone. My name's Ed Schaefer, also Solutions Architect at AWS. Been with AWS for a little over 5 years, based out of the Philadelphia area. And this afternoon, we're excited to talk to you guys about how to build AI agents with serverless, Strands, and MCP servers. Throughout the session today, we'll talk a little bit about what agentic AI is, how you can build AI agents using Strands, how to integrate external and third-party tools, some deployment options. We'll be focusing on serverless technologies today, walk through some of the architecture and workflows, and we'll get into a live coding demo, which we've made enough sacrifices and prayers to the demo gods today, so hopefully everything works out. Let's start off of understanding why do we need an AI agent, right? LLMs are pretty powerful. We can get a lot of things done with large language models today, but they're passive, right? Out of the box, an LLM will take your request, generate some response, document, text, picture, audio, whatever it is, and give it back to you. But it's limited in the sense of its knowledge. An LLM is only aware of the data and the knowledge that was fed into it during the training process. So it's just a single snapshot point in time. It doesn't have any awareness of what's going on in the world or necessarily context about your specific use case. So that's where AI agents come into play. They can help take action where an LLM is normally locked in its silo. An agent will allow your model to reach out to access external systems, to access external APIs, to conduct actions and perform tasks on your behalf, and really give you the opportunity to build more robust workflows and really make your life a lot easier. Is anyone, just a show of hands, has anyone used any AI agents or automated workflows recently?
Nice.
Few hands, awesome. I know there's a lot of examples out there of just simple daily improvements, right? I have an agent that kicks off every morning, scrubs through my Outlook calendar, gives me a report of everything, checks the weather, and just kind of gives me a quick daily briefing. Things that would take not a ton of time in the morning, but just a few seconds or a few minutes that it saves me is pretty great. At the heart of every AI agent is what's called the agentic loop, and this is what really enables the intelligent, autonomous behavior. It's through a cycle of reasoning, tool discovery and selection, tool execution, and then finally response generation. And really, it starts with a prompt, right? So it starts with the information that you're feeding into your LLM-based application that invokes the agent. The agent then cycles through, invokes the model, conducts reasoning to understand what is this request and what do I need to do to satisfy this request. The agent will then look at the series of tools that are available to it, like a carpenter building a bookshelf, right? What do I have available? I have measuring tape, a saw, hammer, nails, what have you. The agent will look at everything that's available and decide which tools to use and when. Throughout this loop, the agent will execute each tool, receive the information back, and then kind of look back on itself and say, all right, this is what I have. My context has been updated. What do I need to do next to satisfy this final end result? Do I need to do anything else? Do I need to use another tool? And then if so, execute that tool, bring the information back, and just continue through that process of execution, reevaluation, until the final goal is reached. Now, so quite a few of you are using agents and using some automated workflows. Who here has built their own agent before? A couple of hands. Was it easy? Was it a little bit difficult to get started? I see some head shakes, not so easy. Fortunately, in July of this year, we released Strands Agent as an open source project. Strands Agent SDK is an open source Python and now TypeScript framework that dramatically simplifies the process of building an agent. And it's built on kind of a simple premise that you should be able to build a production-ready agent in just a few lines of code, right? We shouldn't take you months of coding and deep knowledge and deep expertise to be able to get started and build something to start testing your use cases. Strands is simple to use and really eliminates the need for building complex agent orchestration and defining complex workflows by actually embracing a kind of model-first methodology. Strands, rather than forcing you to define your orchestration and your workload patterns, will actually use the state-of-the-art LLMs to conduct the reasoning and planning and workflow design. It uses everything to plan, to chain thoughts, to call tools, and to kind of reflect back on what's been received and what's been achieved. So for those of you that watched Swami's keynote yesterday, we kind of mentioned there's 3 components to every agent. Does anyone know what those components are? I want to shout out. Say that again? Resources? Yep. Any other?
Maybe it will help if we go back to that agentic loop diagram, maybe?
Yeah, let's go
It gives
back.
some hint. Yeah. What do you think the agent needs here? What are the 3 things it needs to operate? Yes, model access.
Yep.
Prompt, yes. Kind of defining the system prompt and persona for the agent.
Yep. And then I heard resources or tools.
Tools.
Right? Perfect. So, with Strands, you're able to use any model that supports tool usage. That can be through Amazon Bedrock and using Anthropic Claude models, OpenAPI, etc. As long as your models support tool execution, the Strands framework will work and will support your use case. And let's look at what a simple agent looks like with using the Strands framework. So we have here, first thing we need is a prompt. So we define, invoking the agent class, we define a system prompt, and just saying, you're a helpful assistant, you provide concise responses. Now, what you don't see here is a model defined, right? So we do need a model, but with Strands, if you don't define that model or model provider, by default, it will use Bedrock as your model provider, and will use Anthropic Claude Claude 4 Sonnet, right?
Yeah,
as your
that's right.
as your default model.
And just, sorry to interrupt. If, just so you know, we will actually be seeing the code. We'll be coding, deploying and stuff. We are showing you the sample code here. It doesn't mean this is the only code talk we'll talk about. So this is, we cannot show all the capabilities while doing the live coding today. So these are some of the capabilities and the concepts which you want to show before you go into the code. Yeah, sorry.
Yep, perfect. So in this example, it's pretty simple. We're essentially creating kind of a basic chatbot, right? We're not providing any tools right now. We're just providing an interface for an end user to interact with a large language model. The agent will invoke the model and then get a response based on whatever was passed in. Now, if we take a look a little deeper, this is a code example of defining your model provider and your specific model. So there are a series of supported model providers with Strands SDK, Bedrock, SageMaker, other third-party providers, Gemini, OpenAPI, and more. Once you define your model provider, you'll pass in the model ID. So if you're using Bedrock, check the Bedrock documentation, or through the CLI or API, you can get the list of the proper string for your model identifier, and you can further customize how your agent is using and invoking that model by introducing hyperparameters and other customizations to fine-tune your specific use case. Just like you saw before, the agent will invoke the model and get a response. Quick example, or dimension, you can use third-party model providers other than Bedrock, other than SageMaker, if your use case fits that. In Matt's keynote on Tuesday, he kind of emphasized the importance of model choice and flexibility, right? Not every model fits every use case. Sometimes there are models that work for certain use cases better than others. Maybe it's a specific type of generation, specific task. Maybe there's a price performance component. With Strands, you have the flexibility to make that choice, to tune your agent, and to configure it in a way that meets your needs and your use cases as you see fit. So without tools, like I said before, an agent is just kind of a fancy chatbot. It will receive the prompt from the end user, send it to the LLM. There are no tools, no other external connections available for it. So all the LLM can do is use the information, use the knowledge that it has, and return your response. What you see here is defining a simple weather tool where every day is sunny, which is nice. I am based in the Philadelphia area, and it is always sunny in Philadelphia. So with this, we're using the tool decorator to basically tell Strands that this is a tool. That decorator essentially acts as a wrapper around this Python method. It will extract some of the available metadata from the function, the doc string, if there are any type hints, all that information, bundles it up into an OpenAPI compatible spec that the agent will then use to understand what tools are in its toolbox and how to use it, what inputs are expected, and even what the output format should be. So this is just one example of defining a custom tool. In this case, we're using a decorator. We are also passing it in to your agent. So when we initialize the agent. In our code, we define what tools are available to it. You see the weather agent here, which we're defining custom in this block of code. You also see the calculator tool mentioned in the code here. This comes from the built-in set of tools that Strands has natively out of the box. So you have some pre-built tools available like calculator, local file interactions, file system interactions, streaming data, API, REST API, HTTP requests, things like that. But we're giving it a smaller set of tools available so it can do its one specific task of math calculations and weather prediction. But there are other systems that we might want to integrate with in a business environment. A lot of times there can be hundreds, there can be thousands of systems that you need to integrate with. And those could use a variety of different methods. Some can be through REST APIs, there could be SOAP APIs, WebSockets, SQL, Oracle, any number of things. To build custom integrations for all of those different use cases and ensure that every model that you could possibly use can interact with those integrations, it's a pretty heavy undertaking, right? So how do we make that easier? How can we build integrations for all the systems that we have, make them functional, and make them easily available to all of our agents?
With that, the solution is MCP. How many of you have heard of Model Context Protocol or MCP? Nice. How many of you have used it? Okay. So anybody can tell us like what kind of problem it solves? Please. Go ahead.
It provides a common interface to third parties so that the model can actually speak in that language.
Exactly.
API interface.
What was the problem before that, if I can ask?
Those were walled gardens. You didn't have access to the guts of whatever you're interacting with.
Exactly. Thank you for that. So yeah, for everybody in the room, quickly, MCP is an open source standard for connecting AI applications. Earlier, think of it as microservices talking with the REST APIs. You need to know the spec, what method, is it a get or post, what parameter it needs. There was a standard, and that's how you communicated with different microservices. These days, AI agents need to talk to such tools, and they need such standards too. And that's what MCP is. MCP is basically open source so that every tool provider and every AI assistant can talk to each other in a unified language. For example, as you can see, AI assistant needs access to sometimes local files, sometimes databases, sometimes remote service or MCP's tool for that matter, and you need such common spec which everybody understands. Think of it as like a USB-C port for AI applications. But why we are talking about MCP today, most importantly, is because in real-life applications, any ISV providers where you talk to the softwares, and if they are implementing their service as an MCP server, how do your AI assistants, if you are building an AI agent, how do you talk to them? So with Strands, because specifically we are talking about Strands today, Strands has a built-in integration with MCP servers. It comes with all the native MCP client definition, so you don't have to adhere to the spec, go to the Anthropic website and read the spec and design all those hard-coded boilerplate code. That it does it for you. And we'll see it in action in our code today. Visually, as you can see, imagine you have three, on the left-hand side, 3 AI assistants, and which needs to talk to multiple service providers or tools on the right-hand side. If it is, let's say, tomorrow you add, instead of Cloud Code, tomorrow you want to add something else, let's say Kiro, for example, and that also wants to talk to Git, or that wants to talk to Google Maps. Without MCP, it will be like M cross N problem. With MCP, basically it becomes you implement it once on the server side or AI assistant side, and same thing, the server, the MCP server provider or the tools provider implements it once. So it becomes N plus N problem rather than M cross N problem. And this is huge. That's why every startups these days, ISVs, are going to this MCP protocol way of doing things, providing their services. So Ed briefly talked about how do you integrate AI agents with multiple tools. Some are built-in strands, like weather API call he mentioned. Then there was also a custom code, what you write, Python code, and you do @tool decorator, and that becomes a tool. But that was still, everything was local. Now with MCP, how do you integrate MCP tool which are hosted somewhere else remotely, maybe in your on-premise applications, servers, or EC2 or Lambda functions? How do you integrate those? So what Strands does is it gives you the MCP client, multiple transport layer it supports, STDIO for local connectivity. Here we are using streamable, Here we are using streamable HTTP client. This is mainly used for having the streamable response. And the URL you see is typically in real world, it will be like API gateway URL or load balancer kind of URL fronted by your MCP server. So when your MCP server is hosted somewhere, of course they expose an proxy layer, and this is that URL which we'll see in action. Once you have the client initialized, just like any other code, this is still a Python code as you can see. This line, list tool sync, is basically gives you what all tools this MCP server provides. Typically, a server does not provide just one functionality. They provide many functionality. For example, in GitHub, if you talk to GitHub MCP server, it doesn't just let you to git clone. It also lets you to git commit, git push, multiple features, right? Multiple function calls. And this list tool is basically gives you all the tool which AI assistant can understand and call. And this will help LLM to decide what tools you need to call and in which order. And that is how it is making the AI agent more powerful, basically.
I think there's also a very powerful feature there with the list tools function. Mainly, if you're building MCP servers maybe within your own organization and different teams are building tools to expose to other teams, each team that owns the MPC server, or MCP server, they just have to update their endpoint, right? Your agent will dynamically, when connecting, will dynamically load that list of tools, and as new tools or new functionality becomes available, it will automatically understand, hey, I have these new features, I have these new things that I can do. You don't have to redeploy your side of the application, rebuild, reintegrate libraries or anything like that. As soon as they deploy and update that tool list, it's ready for your use and ready for integration.
Right. So now you have AI agents, which is a Python code. You have MCP server somewhere running. We'll show it in Lambda today. But why we chose serverless today to build this? It can be on EC2, it can be on-premise. But just like any other application, AI agents are just Python code at the end of the day. So how do you want to run it? You should only run it or basically pay for it when somebody is using it. You don't want to run it on a platform where you are paying for 8 hours when nobody is using your AI agent, right? So that is where you have the pay-per-use kind of functionality with serverless. At the peak usage, let's say Black Friday, you have an AI assistant who is helping you to do some shopping. On Black Friday, you want to scale that high, right? And with serverless, it happens out of the box, and it goes up and goes down based on your peak usage. Again, security and observability is built in, just like you might be aware of with any other application. There's no fancy stuff. It stays. With serverless and the AI assistants, you get it out of the box. All the cool metrics is what you get, like how much time it is taking, what's the duration, if something fails, how do you go and debug about it. And this is exactly what we'll be building today. So as you can see, this architecture has two blue boxes. So the smaller blue box, this is called MCP server. We might not have enough time to build this from scratch, so we have already deployed this part. So there's a Lambda function, MCP server, and this Lambda function has a very complex implementation of MCP server. It can roll a dice. But the important part is not the functionality of it. What we are trying to show is how do you secure your MCP server. Tomorrow, if you want to build your own MCP server, how do you secure it? You don't want any AI agent or assistance to DDoS it, right? So that's where we'll show how you secure it using Lambda authorizer. If you do not pass a proper auth token, you cannot call your MCP server. This is how the real-world applications are implemented these days. Lambda authorizer is one way. Of course, you can have OAuth token and many other ways of securing it, but this is one way which we'll be showing you today.
And just quick show of hands, who here is familiar with building on Lambda or has experience building Lambda functions? Perfect.
Thank you so much. The second part which we'll be building today is this bigger blue box, which is the agent using Strands. Again, we will be implementing this on Lambda, fronted with API gateway. So when the end user is sending a request or the user prompt, this AI agent, as we saw in the agentic loop, it will talk to the model of Bedrock. It can be anything. It just doesn't have to be Bedrock. It can be OpenAPI, it can be Gemini, anything. That's the power of Strands. This LLM will help this AI agent to come up with a plan. Okay, based on your user request, you need to call one tool, two tools, or three tools, whatever is implemented here. So first tool, let's say if user is only asking about weather, you only need tool number one, which is built in, http:/request, go to the website, a third-party website, crawl it, give me the weather. But if, say, the user request is not just about tool, but also a lot of walking is happening in Las Vegas, how should I commute today? Should I walk? Should I take a cab? So that's where we have a custom tool called Commute Advisory, and it will, of course, check how the weather is. If it is raining, it will not suggest you to walk without an umbrella.
If it's raining, you don't want to ruin your super stylish gold jacket.
Yeah, of course. And the third tool which we'll show today is the integration with the MCP tool. So how this AI agent, for some reason, if I'm walking based on the commute advisory of the AI tool, because we're in Las Vegas, we need to roll a dice, at least. So this is the third MCP tool which we'll call today to roll a dice and see how AI can intelligently do the reasoning and come up with the steps, which tool to call in which order. And yeah, so any questions before we dive into the code for this one? Cool. I think before we go into the code, just one last slide to go over the workflow, what you should keep in mind before you see the code so that it makes more sense when we start building.
I'll take this while you prep over there. All right, so yeah, let's look at the example that we'll be walking through end to end. It's really going to demonstrate kind of a simple agent that can check the weather, determine what you should wear and how you should, for your commute, how you should travel, and like Rahul said, because we are in Vegas, we might as well roll some dice. So we'll give our agent a pretty simple prompt. How should I commute today? And we're telling it, hey, I'm in Vegas. Let's roll a dice, gamble for me. What are my lucky numbers? Notice we're not saying, we're not asking about the weather. We're not saying, tell me how I should commute based on the weather. It's going to figure that out for us. And we're, like I said, we're letting the agent decide what tools should be executed and when. And then based on the information that it's receiving, we can provide it some information on what a comfortable range should be and good modes of transportation for different scenarios. And then those two, the weather and the commute, will be built with custom tool integration, like we saw before, using the tool decorator. And then for the MCP integration, we have the MCP server running a dice roll tool. When the agent completes its loop, executes all the tools available, does its reasoning, and determines it has everything it needs, we should get a result showing the weather and how we should commute. So let's build. Whoa, that's Earth.
Right.
All right, so let's take a quick peek at the MCP server.
The small blue box which we saw in the architecture.
So this is our remote third-party tool, right? We're not building this MCP server directly into our Strands agent. It's running off to the side. Within this code, we have a simple function defined to parse our dice response. This is where we're basically invoking Bedrock as the backend to actually execute sort of essentially random number generation. This could easily be some other API, some other method that will generate that response. Here on line 47, we're building what's essentially the entry point for our agent. This is the tool that the agent will directly invoke. We're using the MCP tool decorator to denote that it's one, being delivered through MCP, and two, it's a tool. Within our doc string, we're giving it some basic information saying that this is a tool that will roll dice. We'll go through.
Just to answer your questions, so we are also showing here DynamoDB. We don't need it. Here, whatever we record or roll a dice, we are storing it. But the idea is you can use this kind of architecture to do the state management within your MCP server.
And in this scenario, we're storing the result of that dice roll into DynamoDB, built into Strands. There are other options for persisting conversation and context for memory and session management. So you can use DynamoDB, you can use S3, you can use some others in memory for storing that contextual data and reusing across sessions. Now, one thing we don't want to happen with this MCP, because it is extremely sensitive, we don't want just anyone to be able to go out and roll dice. That would be crazy. We are, with our API gateway, using a simple Lambda-based authorizer. For those of you who are familiar with developing applications on Lambda and using API gateway, this should look pretty familiar. In this case, we are API gateway will send authorization headers and bearer tokens into this Lambda function. The Lambda function will parse and validate the token against our algorithm. In this case, again, super secure. We're checking to see if our token is quote unquote good token. If it's not good token, kick it out. It's a bad response. You're not authorized. Simple use case. Clearly, you could use any other identity provider that you may have. Most identity providers that have some integration or some examples with API gateway or with Lambda authorizers will have a boilerplate code on, that you can place in here and have real security versus versus our super strong
Yeah.
use case
The
here.
most secure MCP server we can ever make.
Yep, and then at the end, once everything is validated as good, or if it's denied, we're passing back the IAM policy of either allow or deny for this particular resource. That gets kicked back to the client, and API Gateway can determine whether or not it can move forward.
Yeah. Just like any other application or Lambda function, you want to test it before you expose it to any AI agent, right? So let's quickly test if this dice roll works by itself or your MCP tool works by itself. So MCP or the Anthropic provides a tool called Inspector to test your MCP servers. So once you run that, it gives you a nice little Postman kind of UI. When you say yes, so what it does is it gives you, as you can see, this nice little UI. It comes out of the box. This is the very basic way of testing your servers when you build it. So let's try to connect to our dice roll server and see, before even AI agent can talk to it, let's see if this works by itself standalone. Oops, it doesn't. And as you can see, it says user is not authorized to access this resource. Any guesses why? Not a good token. Exactly.
Did you use bad token?
It is a bad token. Not a good idea.
You can't use bad token, only good token.
Let's see. Try to connect again. Cool. So now only authentic AI agent, which we will build on Strands, can call this if they pass good token. So what are the tools it supports? This can support multiple tools, but right now it is only supporting one tool called dice roll. So let's see if it works. So I'm not saying one dice. I'm saying in a natural language, roll a dice. So we have to convert this into one dice somehow, because we know LLM should be able to figure it out for us. So when you run this tool, and this Lambda cold start here, which is once. So as you can see, we said a dice. It figured out, oh, you are asking for 1, and I roll 2. And because it is just 1, the sum is 2. If I say roll 3 dice for me, it rolled 3 dice, and the sum is 15. So this is the one functionality which our MCP server is working, tools are working. Now let's get back to the AI agent building part. So as you saw in the building agent, there are 3 core components. One is the system prompt, one is the tools, one is LLM. So system prompt is basically what you can do. What is your persona agent? You are doctor, engineer, travel agent, whatever you are. Here we are clearly saying you are weather, commute, and dice rolling assistant. And give some system prompts. And at the end, important thing here is these are the tools I have access to. You, Mr. LLM, help me figure out what tools I need to call for this particular request which user is asking me for. So, and in what order. So once you have that, we start with the base tool of HTTP request, which is inbuilt with Strands, and the commute advisory tool, which is just our custom code. It can be based on the weather information what we get. You can say whether you should walk or not. It can be anything. You can just simply say, return always walk in Vegas, which is not a good idea. But the goal is, this is your code, and @ tool decorator will make it a tool, basically, which AI assistant understands. So we'll keep some logical implementation here, not changing this part. But now you have custom tool, which is commuter tool, and now you have one built-in tool, which is a weather API tool. Let's start with that. We are not calling it MCP. Why? Because what if your remote ISV providers is down for some reason? Maybe they are running on some other cloud which is down. So in that case, your AI agent should still be able to work with the limited functionality. It should not just say, okay, I cannot do anything because I cannot roll a dice. So what we are trying to do is, if you can connect to a remote server, MCP server, sure, I can add more tools to this, to the base tool. But if not, I can still work with the base tools. This is one of the best practices of making your AI agents. Make sure that when you're dependent on the third-party tools, you have some proper error handling in place. Otherwise, your agent is like confused. Oh, I cannot call this method. I'm useless. You don't want to do that. So now there are three important things. First, we'll create an agent. For that, it needs a model, LLM access. So let's see, and of course, we'll use wipe coding. That's cool. Everybody uses this. So we can say, okay, model equal to Nova Pro. Okay, that's fine. I want to use Nova Pro model instead of default Claude Sonnet 4.5. Then you can say, okay, for starting an agent, I say, okay, I need an agent where the system prompt is what you saw here. And then model is this model, which we defined. And the tools is all tools, which is a combination of MCP plus local tools. Once you have all this agent defined, let's make a call to this agent. Now we have this code initialized where you are actually building an agent just with a couple of lines of code. So let's try to deploy this. We have created some shortcut so that it builds. While it is building, we are using SAM template for building. But anybody knows what SAM is? Exactly. So do you have that clicker thing?
Oh, sorry.
Yeah, no worries. So what it is doing is you can use CloudFormation, you can use CDK, you can use SAM. We are using SAM because it's easier for this kind of demo. But you can also use Terraform. That is not the main thing what we are trying to show here. So while it builds, what it's doing is it is deploying your Strands-based AI agent on Lambda. It is creating an API gateway in front of it. And as you can see in this code, we also give the URL for the MCP server to connect to. So this is where we have already deployed an MCP server. This is the API gateway URL. Back of it is MCP server running on Lambda, which is the dice roll. All right, now we have 5 minutes left, and we have 5 minutes to test our AI agent. Let's see if it works.
Fingers crossed.
Fingers crossed.
I have faith.
All right, so let's do the individual test first rather than giving the full prompt and see if individual tools are working. Let's just call test weather. So what it is saying is I'm calling my AI agent with this prompt. How is the weather in Las Vegas? And it failed. You know what? I'll just copy this code because we don't have time to debug. Otherwise, I would love to debug with you. Maybe I missed some syntax here.
What about the just dice roll?
Yeah, how about we just try to, no, but it goes to the Strands agent itself. What was the error? Do again. Oh.
We did not make enough sacrifices to the demo gods today.
But yeah, we still have a few minutes. I think we can still test it. Any other questions? Yeah, you want to walk through it?
Let's see.
So this is the total code for creating an MCP server dice roll. As you can see, it is like 70 lines of SAM template. It's very much similar to any other Lambda function or API gateway with DynamoDB.
Oh, that's fine. I don't think I broke the table.
Sorry?
So with SAM, SAM is an extension of CloudFormation. So it allows you to simplify your templates a little bit, especially for for serverless technologies specifically. So we are in this template defining just a simple API event with MCP as the path and a very simple token authorizer that's referenced down here as a function. No fancy special configurations, typical out-of-the-box API gateway, fairly standard.
Yeah.
We are just about
10 seconds, 5, 4, cool.
All right. Try that again. Careful with this table.
What was that?
Table's a little,
Yeah.
seen some abuse this week.
All right. So how is the weather in Las Vegas? Let's see if AI agent can figure it out. So it might be initializing two Lambda right now. One is the agent and one is the other one. So what it is saying is today is sunny weather. This is real time. This is live. If you can maybe verify from your phone. So this is sunny weather, 54 Fahrenheit, 3 miles per second, 3 miles per hour from the northwest wind. So how about, I know the weather, but I'm not asking you about the weather. Just tell me about the commute. So now AI agent will figure out that it also needs to call weather API or weather tool because it has access to all the tools. It cannot randomly say, okay, you just bike or walk today. So what it did was it first figured out the weather. It says, okay, it's sunny, no chance of precipitations, so making it ideal for walking and biking here. If you choose to drive, remember to wear sunglasses. So let's do one bigger, like using all tools. So let's say if I say test all. So what the prompt here is, how should I commute today and also roll 2 dice, which we saw in our workflow in the presentation. And let's see in the real world how the AI agent talks to the LLM and figures out. So it says, if you see here, it says it called 3 tools, weather, then commute, and dice roll. These are the exact tool names, like dice roll, HTTP request, and commute. And what is the response? It's saying, this is the weather. Based on the condition, you should commute, your commute should be straightforward. Additionally, you asked me to roll 2 dices. 6 and 2 is the total, so totaling to 8. So it actually called 3 tools in this sequence without us telling what to call in which order. So to answer your question, sir, this is how it will determine. And if you liked our session, so we are asking AI agent, how was the session? Because we almost finished it. So we are asking, will we get 5 stars from you all? Let's see if it can figure that out. What do you guys think? Will we get 5 stars from you guys? Yeah? So let's see. Let's see what agent says. I cannot predict the exact review, but I'm sure it will be amazing. If not 5 stars, at least the AI agent will give it a solid thumbs up.
Nice.
Keep going and have fun with that. Thank you for having us.
Thank you.
And thanks you for joining.